Okay, here we are. Let's take a look at this problem. I've already written down the thing, so let me zoom in just a little bit. There it is. Let's look at the figure skater. Spinning with an angular velocity of, this is a good test question, 15 radians per second, and then comes to a stop over a brief period of time. During this time, her angular speed is 5.1 radians. Determine her average angular acceleration and the time during which she comes to rest. Notice they didn't give us any r here, no radius or anything, so we're not going to worry about the centripetal acceleration, which is a linear thing, or the tangential acceleration. We're just looking at this. Whoa, that got big. So I wrote down, so we need to find alpha, and t. Okay. Well, I always like using, just like we did back in the day. Let's use this one because we know this, and we can find this pretty easy because we were given all this information, and we can find the time, and then we can just plug that in and find the acceleration pretty easy, right? So let's do that. We're going to say, okay, well, or, you could have used this one. No, you can't use this one. Or you could have used this one because she came to rest. The angle displacement, and to find alpha, and then plug that in. Then plug that in to find this guy. Okay, to find the time. All right. So I'm just going to do it this way. So it looks like the average is going to be 15 plus 0 divided by 2, which is 7.5 radians per second, right? And alpha, theta final, not theta, it's equal to 5.1 radians, which is equal to 7.5 radians per second times the time. So when I divide this out, I'm going to get the time. So I get 5.1 over 7.5 seconds is equal to the time. Well, that's pretty easy. And then I could use that number . 0.68 seconds. Came to a stop pretty quick. That's all there is to this. Okay? Now, let's look at the tennis racket problem, and then we'll be done. Because otherwise, I'll be abusing you probably. I was going to look at the centrifuge problem, but I'll probably start the centrifuge problem on Tuesday. Okay? So let's look at, I don't want to look at the blade. I want to look at this tennis racket. This is good. For insight into this problem, you can check that concept example 7. But it says, during the tennis serve, a racket is given an angular acceleration of magnitude of 100. Now, angular acceleration, that is not the tangential acceleration. That's AT. This is alpha of 160 radians per second. At the top of the serve, the racket has an angular speed of 14 radians per second. If the distance r between the top of the racket and the shoulder is 1.5 meters, find the magnitude of the total acceleration of the top of the racket. All right. The total acceleration, the top of the racket. We can do that. So but we're only given 3 numbers. 160, 14, and 1.5. Okay, so with the tennis racket, that still looks awfully big. Oh yeah, that's because I zoomed it in a little bit more. Oh shoot, I gotta go. I'll let you go.